So we've been talking about irrational and rational numbers. And whenever we're dealing with a irrational number, we want to make them easier to work with. And right now, what we're going to start looking at is simplifying radicals so that we can get the rational numbers out and we're only left with a little tiny radical. So we're going to start with something basic. We're going to start with prime factorization to determine the simplified radicals. We're going to take 63 and we're going to do all that prime factorization. We're going to divide it by 3, gives me 21. 3 divided by, sorry, 21 divided by 3 equals 7. 7 divided by 7 equals 1. So what we do is we set up our two sets of brackets because we're dealing with the square root. And the only thing we have a 3 that'll go in one set, and a 3 that'll go in the other, and we have a leftover 7. So what that means is we have the square root of 3, and 7. 7 didn't fit into one of the brackets, so it's going to stay under the radical. I'm going to take one of these out, cross out the other one. So I'm left with 3 square root 7. And you're finished. That's a simplified radical using prime factorization. We're going to try one a little bigger. We've got the third root of 108. So we take 108, we divide it by 2, and get 54. Divided by 2 equals 27. 27 divided by 3 equals 9. 9 divided by 3 equals 3. 3 divided by 3 equals 1. So here are my prime factors. Now in this case we're doing the third root, so I need 3 sets of brackets. And the 2's don't fit because there's only 2 of them. So I take a 3, and a 3. And I'm left with 2 squared over here. So that means under the radical you have the third root of 3, 3 times, I'm just going to call it 4. So what number multiplied by itself 3 times? Well, that would be this one. So the 3 comes out and I get rid of the other 2. And I'm left with 3 third root of 4. That is a simplified answer. I can't do anything with the third root of 4. I don't know what it is, so it stays as irrational. But I did know that the third root of 27 was 3. Try 128. We have 128 divided by 2 equals 64. 64 divided by 2 equals 32. 32 divided by 2 equals 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So, this case we're doing a fourth root. We're going to move some stuff over here, make some room. Move this over, bit more. Get the 3's back in the brackets. This 2 squared goes on the outside, put that 3 in there. There we go. Now, 4 sets of brackets. 4 brackets. So we have 1, 2, 3, 4, and then the leftovers go on the outside. So a 2, a 2, 2, 2, 2, 2. And now there's 3 left over. So I get 2 to the power 3. So not enough. So if I put a radical over top, take 1 to go out, cross out the other 3. 2 to the power 3 stays in, I get 2. Fourth root of 8. So I create the number of brackets based on p-index and determine what numbers can fit into them, and the leftovers stay under the radical. I'll do one more quick little example for you. We won't use prime factorization. We're going to use something 108. Another way of doing this is you take your perfect squares, 4, 9, 16, 25, 36, 49, 64, and so on. And I try and see which ones work. What happens here is I have the square root of 108 is 36 times 3. Why did I pick 36? Because 36 divides evenly into 108. This, the square root of 36, is equal to 6. Square root of 36 times the square root of 3. This is one of those little rules that you learn. If they're under the radical and they're multiplied, I can separate them. And we know the square root of 36 is just 6. And you're left with the square root of 3 because you don't know what it is.